Today I'm going to teach you how to solve questions involving vectors. Let's look at the question. An airplane is heading in a direction of 20 degrees north of east. Its airspeed is 400 km per hour, but there is a 120 km per hour wind from the direction of 30 degrees south of east. What is the airplane speed relative to the ground? In what direction does the plane end up flying? When you read this question, let us highlight the important terms. First, there's an airplane flying in the direction of 20 degrees north of east with the airspeed of 400 km per hour. Next, there's a wind with 120 km per hour from the direction of 30 degrees south of east. So in the end, we need to find what's the airplane speed relative to the ground and what direction. So how to solve this kind of question? Of course, the first step, we will draw the diagram. So if you look at the diagram, so this is north, east, south, west. We are going to draw for the airplane's direction first. For airplane is 20 degrees north of east. Where is north of east? So this is north, this is east. So north of east means from east here, 20 degrees. So how to write this airplane in the I and the j term? So if you look at the direction here, 20 degrees north of east, how do we get this resultant vector? So it's actually moving to the right side and moving up with 90 degrees here. So this is for the airplane with the airspeed of 400. So how to write it in the terms of velocity of the plane in ij form? So let VA, velocity of the plane. So in this case, VA equals to, so for this horizontal component, it will be 400 cos 20 I. For horizontal component, we have I. So for this vertical component, it's positive as well because it's going up. So we have a plus 400 sine 20 J. So this is just for the velocity of the plane. How about the velocity for the wind? If we draw another diagram, just for the wind only, 120 km per hour wind from the direction of 30 degrees south of east. So if here N, E, S, W, from the direction 30 degrees south of east is here, but it's from here. South of east, it means from east to south here is actually 30 degrees. If here 30 degrees, here will be exactly the same 30 degrees. So if we draw a right angle triangle here, it's 120 component. So how are we going to write this velocity of the wind? So we let velocity of the wind, let's say VW equals to velocity of the wind. We have to write everything in the ij component first. So if you look at the velocity of the wind, it's going to the left and going up. Going to the left means indicate it's negative. So for the horizontal component, it will be 120 cos 30 I, but because it's going to the left, so there's a negative sign in front. Then it's going up the vertical component, so we have a plus 120 sine 30 J. So now we have the velocity of the plane and velocity of the wind. We want to know the airplane speed relative to the ground and what direction is it. So we have to sum these two velocity to find the velocity of the plane relative to the ground. Why don't we just erase some part of here first. We want to combine the two diagrams. So if we combine the two diagrams just now, this is for the plane 20. We combine with this diagram because it says 30, so it's here 30. So this is roughly the resultant vector. So this is VA, velocity of the plane. So this is velocity of the wind, VW. So the resultant vector, maybe we just use VG. Okay. Okay, let us write VG, define VG as the velocity of the plane relative to the ground. So VG actually is the total of velocity of the plane, VA, and velocity of the wind, VW. So we're going to sum these two items. So if we sum the horizontal component, 400 cos 20 I and negative 120 cos 30 I, so we're going to sum the J component as well, vertical component, 400 sine 20 J and 120 sine 30 J. So we will have the velocity of the plane relative to the ground. And we'll just erase this side, so we have sum out this one here, so I'm going to erase the right hand side. So now we continue to find the speed. How to find the speed of this airplane relative to the ground? If we simplify this VG, calculate it, 400 cos 20 subtract 120 cos 30 I, use your calculator, you calculate, you get roughly 271.95 I. And then for the vertical component, if you calculate this, you'll get roughly 196.81 J. To find the speed, it means we find the magnitude. So 271.95 square plus 196.81 square, and then we take the square root of the sum. So we get 335.69 km per hour. So this is the airplane speed relative to the. So this is the airplane speed relative to the ground. So 335.69 km per hour. So we are going to find the direction of the plane. So direction of the plane is here, theta. To find the angle theta, we take tangent theta equivalent to the vertical component 196.81 divided by the horizontal component 271.95. We solve this, we get theta equals to 35.89 degree. If you look at the direction here, actually it is north of east. So we have north of east, 35.89 degree north of east. So this is the direction, and then the speed is 35.69.